cover things in in a way that should at least start on familiar ground for people who've done a lot of work or are working heavily with relational databases. Feel free at any time during the presentation to interrupt me and ask questions. I have seen the internals of a whole lot of what Couchbase does. I've been working on the technology for a few years now, so I can answer a lot of questions, and the ones I can't, I can point you in the right direction. So feel free to just kind of pepper me with questions, and if they don't fit the content, I'll hold them to the end. Otherwise, I might just answer you as we go. So there's another webinar coming up for administrators. So people who want to put NoSQL in production and want to learn more about how it's going to fit into a cloud context or on your own hardware, how to monitor it, all that sort of stuff. So this talk is really aimed for developers. That was kind of my, the way I got into databases in the first place was as a developer and a user who then got really passionate about Couch and started contributing to open source, and that's what got me here today. And so I'll try to go back through a little bit of my thought process as I was learning, because when I first started with NoSQL, I was a relational database user, using kind of standard LAMP stack and then some Rails, and have tried to stretch relational databases a few different ways before I made the jump to NoSQL. So hopefully I can help bring you along those thought processes too. So the first thing we want to talk about is why NoSQL. And there's a couple of ways to slice it, a couple of motivations for people to get into NoSQL. One of them is really scale and the challenges that come from the growth that we're seeing these days. With so many people already connected to the internet, already holding a smartphone right there, one click in the App Store away from throwing some more load at your servers. So that's why pretty much the conventional wisdom for application tier deployment is that you're going to have a shared nothing architecture on your application servers, and you can keep throwing hardware at the problem as people are growing, right, as your load grows. But if you're using a relational database or any other kind of point in your system that has to do heavy lifting and is also hard to scale horizontally, right, you're going to end up needing to make that computer really big and really fast, and you get diminishing returns on your hardware investment, and that's what that curve in the lower left corner there represents. So some of the promise of NoSQL is to flatten that curve out and make it so that NoSQL databases can be deployed on commodity hardware clusters and scaled to meet demand, both scale up and scale down. So it sounds that's kind of the promise, and not all the vendors meet that promise, and a lot of the technology is still young, but that's certainly where the industry is headed. And we think that that's a really key aspect of NoSQL, is being able to trust when you invest in building an application that when the growth hits, you're ready for it. And this is kind of an operations topic, but I think it's important for developers because success is important for developers. So when you see something like Draw Something, which is a social game, kind of seems silly, but one of the things about it that sets it apart is it's kind of one of the fastest growing online anythings ever, as far as like a new title or website or whatever coming online and attracting traffic. This is the first month and a half or so of growth, and you can see they got up to 15 million daily active users, thanks to getting picked up by some celebrities and whatnot. And the orange chart that I've embedded there is a longer term view, the sort of framed what we're seeing zoomed in on here. And in the longer term, they got up to 35 million monthly active users. So to put that into a little bit of perspective, what kind of load does that mean? Well, first we can compare it to this other orange chart I put up, which is monthly active users for Instagram. The jump at the end is when they added Android support, and that brought them up to 7.5 million. So Draw Something, we're looking at about 5 Instagrams of scale, and that is over the course of, about a month and a half. So the window we're really interested in is that first part when the wave really hits, right? Because that's the part when, as someone who created an app or a product or a website, that's the part when you're most likely to be caught off guard. So these first few weeks of scalability, you can start to well anyway, there's a lot of interesting kind of texture to this story, but the key points are that they made it across that whole curve without having any downtime, and a lot of that was we were on the phone with them helping make sure they were running the right hardware for their workload, and we got an up close view of what it takes to do that over such a quick time span. So to show how important it is to be ready for this growth now that everybody already has a smartphone or web browser and they're ready to visit your site in a click, here's the Simpsons game, which was set up for success. It had the same initial growth pattern that you see with Draw Something, but it was only just a few days in after launch that it had to be pulled from the App Store because the back end couldn't keep up with the demand and the game was getting too sluggish. So it's that's the difference, right? Your back end performance can make that, and scalability can make that difference between success and failure in these cases. So that's the conventional answer to why NoSQL at scale. If somebody wants you to give a really hard answer for why you want to move to this untested waters and try something new in your application, well, the thing is that's not the only answer. And as we've asked around and kind of asked ourselves what appeals to us so much about about using the document model, using JSON, NoSQL, and having more of a key value approach to data. One of the key things that jumps out is flexibility. And so we asked around. We did a survey of people who were already interested in NoSQL, already using it. So it's kind of a biased survey. But then we asked them, what is the biggest data management problem driving your use of NoSQL in the coming year? And we were surprised because we thought the answer was going to be scale and performance, which turned out to be near the top of the chart. But the real big thing people want to see from their database when they're looking at NoSQL is flexibility. So they want to be able to do the things you can do when you don't have to tie yourself to a rigid schema. So let's think about schemas a little bit. I did, my fair share of this sort of thing before I started working on Couch, and the thing I really remember is coming back to an app. You build something like this, and then 6 months later, you come back to the application to do some maintenance work, and you have to spend half a day just poring over the schema and the queries that are run, kind of bootstrap the model again in your mind, figure out, what exactly that data is, right? If you're tracking down some row in a table somewhere that doesn't quite make sense, and now you've got to do a whole lot of, reverse engineering to figure out what it's supposed to mean. And this can be great, right? There are use cases where you really want to tell the computer ahead of time what you're going to give it so that it can store it in a way that's really optimized for that exact object format. But the data is getting messier, and applications are kind of growing. Complexity is growing. You're seeing a lot more workloads that don't necessarily call out for a schema and for rigid data constraints, right away. Maybe it intersects with other systems that do run relational databases, but a lot of, and not only big data applications, but anytime you're seeing messy user-generated data, or an application that has to develop really fast and the schema changes, would just be coming nonstop. Anytime you see that, it's sort of a call for potentially looking at NoSQL. So I put together a list of kind of triggers, things that would suggest spending a little time looking into SQL, wouldn't be a waste, right? It could potentially bear fruit. So if you have anything like this going on, there could be some help in NoSQL for you. So the first two, the tables, that have lots of columns or lots of nulls, that's really just a smell that indicates your data is heterogeneous, and all your, everything your users submit looks kind of different. So if that's the case, then you're either going to have these wide tables with lots of nulls, or a really highly nested or self-join kind of pattern to capture arbitrary attributes. So that's a little bit the third pattern there, the entity attribute value pattern, which allows you to kind of simulate RDF in your relational database. If you see yourself doing any of these things that indicate that you're pushing the relational model kind of to its extremes, right? If you feel like you're already torturing your query planner, maybe you should look at NoSQL. So this fourth point I put here, messy domain models. I have my war stories of this, building what started out as a Rails app that ended up, having the back-end business logic functionality overwhelm the entire kind of presentation layer. But by that point, it was already, a bunch of active record models and tables and migrations and doing everything by the book. And, you end up with this third and fourth normal form kind of approximation of a messy real-world domain. And then you end up, kind of getting this leaky abstractions in places where and I'm sure if I was like way better at relational databases, I could go over that or do kind of a hybrid approach. But in this case, I was spidering the web and downloading all the MP3s and parsing their metadata, their ID3 tags, and building a recommendation engine to figure out where bands should promote themselves. So I had that all going in Postgres, and it was working, but it was slow, and I was getting into the let's make this fast phase. But it had been so so normalized that kind of the first thing to do in the let's make this fast phase, I started denormalizing and adding kind of other caching layers. And around that time, I started using Couch to store JSON instead. And instead of modeling my entire application as, setting up this database state to be, the truth of the world, right? And instead I started using this document storage model to record what I found out there, spidering the web, and then, run functions over that to distill it down to the valuable data and, record that again, and then use queries on top of that to present user interface. So it turned into much more of a kind of a stream-based workflow. And I think there's a lot of applications out there that are kind of on the edge of wanting to turn into that, and NoSQL gives you a little more flexibility to explore those kind of models. And anyway, that's a little bit my war story from overdoing it in my ORM, and how moving to NoSQL kind of helped cure me of that. If you have, another sign you might need NoSQL is if you have tables that are undergoing a lot of schema changes. If you're just like always migrating that table, or maybe a set of tables, then that would be a good place to kind of try NoSQL without having to adopt it for your entire system. It could simplify some things there. There are also, a big place where our customers come from. This is maybe pretty common for NoSQL because it plays on the scale, right? The scale reason for getting into it. But you've got, say you were building, a game engine, and you have a logging call, and when you start out, you just log to a table in MySQL, and that serves you for the first, few million users. But now it's time to upgrade to more dedicated infrastructure. And so we'll see people who need to do those kinds of like aggregate queries on larger amounts of data and do it, closer to real time, migrating from from databases like MySQL to Couchbase for, particularly subsystems that have those aggregation needs, but also for other things, that have really high data velocity or otherwise kind of fit in with the Couchbase sweet spot. This JSON, right, has been, I guess there was a moment there 5 years ago when people weren't sure if JSON was going to win, but it's pretty much taken over the way that we send data across wires these days, at least in my experience. So if you're already shipping JSON around all the time, maybe maybe it would simplify things to have that JSON go all the way down to the disk and back up, rather than having essentially a translation layer between your ORM and your API. And that's what I see most application servers as being these days. And you still have, an application server when you move to a JSON storage model, but its role becomes, or can at least become, somewhat simplified, because you're mostly just, handing data between people and making sure that, they're asking for the data they're allowed to see, that kind of thing. So this third to last point here about time-based service level agreements, I think that's a pretty unique one for Couchbase among NoSQL vendors, because we have a managed memory caching layer. And so it allows you, if you keep all your data in working set, to serve workloads that need, constant low latency performance, even, as the topology changes. So if you're using, if you're letting the kernel manage your memory, or if you're, purely disk-based, and then using, like a HTTP cache or something in front, you're not going to have the same control you have over what resides in memory. So we have a lot of experience in, managing working set in memory, and that kind of helps us to automatically, put the right window over your working set. So if you have a game that's popular worldwide, and as the day changes, you're going to have different users coming online and going offline, and so you're going to have different work sets coming in and out, and you need to be able to cope with having more data than can fit in RAM, but at the same time give that low latency experience to the users, once they come into working set. Yeah, I think that's an important driver for NoSQL adoption, especially in the advertising industry, where you've got X number of milliseconds to turn around your request, and you don't know which user is going to be coming over the wire, so you have to keep the entire working set in memory all the time. So anytime you need low latency, you can do it, right? With if you're really careful with MySQL or something, you can get latencies that are close, but it's it's not dedicated for that. And what are you going to do when you have to move from 4 servers to 6? Are you going to have downtime, or is that going to be a smooth operation? So that's a big advantage for NoSQL, I think. Now, if large tables are slowing down your queries, I can't promise NoSQL will help. That's a really application-specific thing. But sometimes it can be helpful to pull something that's overwhelming the rest of your database out to its own infrastructure. And if you're doing something like running aggregate queries over it, or doing other workloads that a NoSQL option would be a strong fit for, then you might find some benefits in addition to splitting out this this store on your site and your database infrastructure, move it somewhere else. And you could, I guess, use the same technology for it on a different cluster, but if it's an isolated place, this is a good opportunity to put NoSQL in production. So if you're already doing joins in your application code, I mean, I put this here as a flag for kind of anything that says you already went through the pain of scaling, right? So maybe you're on MySQL, but you have everything sharded across a bunch of servers, and it's by user ID or whatever makes sense for your application. So if you've already kind of taken the red pill or whatever, you may be in a good position because you're going to be slightly more modular in terms of your access patterns. swap out parts of your application to other pieces of infrastructure. Or, you know, again, maybe you're in the position, vis-a-vis having the experience of done that, to build your next application using a document model. So we're going to talk more about the document model and coming up in the presentation here. Actually, before I go on, I want to make sure that if any questions came up in your mind from this stuff, you ask them. So be sure to just put questions into the chat box there, and I'll address them as they come up. So let's see. Let's go ahead and talk about documents, and then we can come up to any questions that I see here. All right. So yeah, working with documents. It's a little different, but it's, you know, you're a programmer, right? You've seen stuff before. It's not that different. Representing game data in JSON is kind of like what I want to show here. One of our customers, Tribal Crossing, I could have done like a blog with blog posts and comments, but this is just essentially like a small data relationship to show how you can do it using just a pure key value API. So this is going to be applicable across you know, a wide range of NoSQL databases. And the reason we show this for Couchbase is that with the Couchbase key value API, you can get, you know, sub-millisecond latencies, and so that means that sometimes it's pragmatic to, you know, stick to the slightly more limited key value API for certain operations, and then branch out to the fuller-fledged query API for, you know, other kinds of operations. So I'll talk more about that as we go on. So here's the schema for this game. It's a farming game, so you've got a farm, and a player owns the farm, and the player can get plants. And essentially, you know, top level thing to understand here is that first object there is the player object. All we're showing is the name right now, but you could put anything else on there, right? You could put favorite color, or, you know, other kinds of metadata as your application adds attributes to its players. And then similarly, the plant object in the right-hand column is, you know, what you would store additional kind of attributes of plants, like maybe this plant grows faster, or whatever else, you know, happens in your application that affects plants. Now, here plant list is where this gets a little bit interesting, right? Because this is where we've made kind of our first big decision as a developer. We could have just used a query to find all plants with player ID = 1, done an index lookup there. But because we're running this application on like a 25 node cluster with, you know, hundreds of thousands of operations a second, we know that it's going to be faster to just do a direct key lookup than to invoke the indexing system. So that's what this player plant list document is about. It's just a list of plants that belong to a given player. It's there to expedite the retrieval and population of that player's, you know, kind of farm API response. So let's look at the code. We'll come to the code in a second. First, this is a little bit of what they liked about doing it that way. The first two objects, the first two kind of points here come back to that number one reason people want NoSQL. They want it for flexibility. So they really enjoyed not having to run alter table, not having to coordinate that, you know, migrations among all their developers, and the freedom to, you know, if the only code that needs to care about some, you know, little attribute of a plant is in the UI layer, then that's the only code that you have to touch to add that feature. So then there is, you know, the second thing, you know, they I think were originally using kind of serialized PHP objects, but they moved to JSON to open it up for querying with the query API that we'll see later. So we do support arbitrary binary values. You know, we're a in place, you know, upgrade from memcached. So you can do more than JSON, but when you use JSON, then you kind of unlock these additional query capabilities. So here's what they did is in the code, just to make it really clear that they're maintaining that little per player list of plants kind of index as the players are operating on their, via the API server, via their application server. So the app server here is creating a new plant and saving it, and then it's loading up the player, and here there's some stuff going on in the background, loading the plant list and attaching the new plant to that plant list. And now we are going to save the plant list back to the database. So now the player has a new plant. And you can see, I guess, what's notable about this is there's a couple of round trips, right? You have to create the plant, you have to load the player, and you have to load the plant list and save it back. But when you're talking about sub-millisecond latencies, still even those round trips will be less than the other time when your code is executing, and you can still have a fast responsive turnaround time for your end users. So we've talked a little bit about get set, how you can create documents as you're going. So the next topic really is concurrency. Good. I have a question here about query support. Just to be clear, we have query support, and after we talk about concurrency, I'll talk a little about queries. I wanted to do an application example that didn't use queries because that's how you get the super blazing performance. When you have the query engine involved, typically, basically we're talking about disk latencies instead of memory latencies to read off those indexes. So like it's great for leaderboards, but if you can do your direct interactive low latency stuff, like the key value API, then you may be able to get the most performance with a mixed application. As far as slides and everything, that'll all be online. We have the whole webinar series up for you to browse. So let's talk about concurrency and the lack of transactions in NoSQL. So typically a NoSQL database is going to avoid complex transactions because while the algorithms exist to create agreement about state across a cluster, they aren't compatible with high availability. And so we take the opposite extreme as far as having kind of state that spreads across the cluster. We don't want any of that. We're fully a shared nothing system. You'll see some other mixes elsewhere in the NoSQL landscape. Some systems only run on one server. Some systems have servers that play special, and some systems have servers where all the servers are the same, but the clients go through may have a hop as they enter the cluster. They may talk to the wrong server and have that server redirect them. So the Couchbase topology is that the clients are aware of the server layout, right, and can read and write directly to the node that owns the data item. And this gives you some interesting properties. My favorite is that it gives you strong consistency. So for a given document, it lives on one server in memory somewhere, ready to be operated on hundreds of thousands of times a second. So you could have, for instance, like an increment counter that you're hitting from all your app servers, and then take the result, the current value of the incr, and have that go out via a query later on, and use that to maintain your leaderboard. But there's other ways to do it, and I digress. The key point is that you can do these strong consistency, use the database as shared memory approaches in Couchbase that you can't do in an eventually consistent environment, at least on the level of a single document. So there's a strong consistency on a single document, but on multiple documents, there's no ability to create a transactional boundary and roll anything back as you have more than one document in an operation. So we have multi-get and multi-set. Both are they're essentially sugar over the basic operations. They help with some concurrency, But if you do a multi-set, some operations operation seriously. We have operation, which allows you, compare you to, be assured that when you make a mutation on the server, you are doing it to the version of the data you thought you were doing it to. So somebody else gets in there in the middle, you load the document to edit it, someone else touches it before you are able to make your save. You can request that you get an error there, and that allows you to have an optimistic concurrency control and do, and that's what that becomes is a primitive for higher level concurrency operations. So once you have compare and swap, you can build some interesting stuff. You can use it as kind of memory for your Paxos engine, or do other higher level patterns on top of it. But we just want to give you those bare building blocks and let you push any kind of additional transactionality you need out into the application. We also have Git with lock, and this one's different. It's more like if you have an object graph that you're going to load up, so you have a bunch of little documents that all point to each other, and you're going to pull up a subgraph and modify a few of them and then put them all back. If you Git with a lock, then anyone else who tries to Git with lock in the time before the lock expires, they'll get a warning. They'll get an error that says somebody else has that lock, and that allows you. It's more of pessimistic concurrency control, so it will prevent some resource contention. But I don't think it really lets you do anything you can't do with CAS. It's just it's maybe a little more performant way to do it for some workloads. So that's enough about concurrency, except, one more thing. NoSQL thinks concurrency is yummy, right? Remember this, when you're doing a bulk load, if you're like trying to benchmark a NoSQL vendor, you should have, more than one machine at least providing that benchmark load. Because even with one machine and a bunch of processes, doing the best you can with one machine, you're not going to get the same kind of traffic you're going to get with, multiple clients across multiple machines. So a lot of NoSQL is designed for high concurrency workloads, and some NoSQL may have problems with concurrency, but if that's the case, you want to find it out early on. So when you're doing things like bulk loading, hit it real heavy from lots of iron if you can, because chances are it can take it, or you can find the the limits of what your installation can do. So now I want to talk about queries. There have been some questions about queries, and I'm glad we're getting to this now. So yeah, let's talk about queries. So one of the questions I had. And what's important about the indexing is that it is, designed to scale up, even as your data grows across a ton of nodes. So it's not going to quite give you the millisecond latencies, but it still gives you interactive capability, and it is, got some powerful functionality that we'll look into. But first, let's do a little bit of a higher level comparison across more of NoSQL and databases in general. And my apologies, I left the fourth point out here. I would put graph indexes. I think those are getting pretty important. But to get started, there's secondary indexes, which I grouped together. Kind of my motivation for splitting it up this way is that people tend to lump all MapReduce together, and it's not really appropriate. So really what we want to look at is implementations that build an index, right? Or you could have a query model that essentially looks at everything all the time. Or you could have a model where you're doing something that's more like auto-indexing, based on the content, which is more like what a full-text search engine will do. So secondary indexes are, by far the most common indexing use case. You're probably familiar with them from alter table add index. If you've ever run that, right, the thing that comes next is like a SQL statement that tells tells you what exactly about that row matters for the index. And typically that will be a single value, right? The thing to index by, it's a foreign key or something. But you can also do complex indexes, and then you get some additional characteristics. Now, there's a flavor of MapReduce that Couchbase uses, which is essentially the same thing as alter table add index. It allows you, instead of using a SQL expression running on each row, instead what you do is use a JavaScript function running on each document. And so that index is built and maintained, in the background, just like the index you're familiar with on a relational database. But it's the one difference being that it's built on next read instead of when you write, so it doesn't block the write process. It's an asynchronous build. And then once you have that index, it's going to feel very similar to query, right? Because you've got the rows that you chose sorted, collated, so that you can put them out with the contiguous stuff together that matters. So you can build, a key like, the user ID and then the timestamp, and use that to build a view of, all the photos that user took recently, or whatever your application is. So we'll get into some of the queries you can use incremental MapReduce for. It's essentially the same stuff you can build an index about in a relational database, except for index is really only the map side of the equation. So there's some neat stuff you can do with reduce that we'll cover in the last few minutes of the webinar. So then another flavor of secondary indexes are the ones that are a little bit more of like a declarative type format, and those are nice because they're machine readable in a way, but they have they're not quite as flexible as being able to use the full expressive power of JavaScript to decide what to index about a document. So I'll talk more about using indexes to normalize your data, clean up your data after the fact, and how MapReduce can do that in a minute here. So I want to talk about full table scans because they're relevant because they can happen to you in a relational world if you and the query planner can't agree, and or if you just or in other kind of worst case scenarios, or if you forget to build an index, and so these will really exercise the capability of your system to look at all the data that it contains. And that can be kind of a workout. On a small data set, you can optimize for that, and you can kind of make it work, right? And we see that with some of the NoSQL vendors. But with a larger data set, it's going to take hours to stream the full data set in or out of the cluster in the first place. So being able to inspect all that data without indexes isn't really feasible, and that's why things like Hadoop have gotten so popular, right? If you're gonna fold over all your data, run some function on the whole thing anyway, you may as well use a tank to do it, and Hadoop is really good for that. So there's an interesting model I'll talk about again in a minute where you can use the incremental MapReduce to kind of provide a real-time front to what Hadoop can figure out for you. So if Hadoop is a daily job, you can use MapReduce to kind of give you the up-to-the-minute thing that kind of would bridge, what Hadoop doesn't know about yet, and what your system in the whole knows. Full text search is an important one because data just keeps getting messier. It's a really good way to get into messy data. And one of the things that's different about the NoSQL world with full text search, in relational, typically you're going to be running parallel writes between from your app server to your database and to your full text indexer, because the data that goes in the database doesn't look quite like what you want indexed. Now, in NoSQL, your documents are going to look a lot more like what you want indexed. So you can actually have the database engine itself give you a feed of what's new and have it hand that to your full text indexer. So this is nice because it allows you to do some write deduplication on the way into the text indexer. If you have a document that's getting hit real heavy, your NoSQL database isn't going to send it to your full text indexer every time. It's going to buffer it and send it once every few seconds or however you configure it. So it's important. I think it's an important thing to look for in NoSQL is some kind of integration with secondary indexers, because once you have one of them, right, it's really easy to bring other business processes online. If your database can provide an event feed, then you can hook it up to engines that react to that, and do other background processes. So let's look at MapReduce. MapReduce is going to be the way you query a Couchbase cluster, and it allows you to do pretty much everything you can do with alter table, but also to get in and do some new things. So you can do basic key and range lookups like I described for figuring out the recent blog posts or all the plants that belong to Joe. But you can also do some neat stuff like normalize the data after the fact. So imagine you're running, you're collecting crash reports. You have users running your application all over the world, and they're running old versions and new versions, and it's crashing all the time, and those get sent to your server and logged. And now it's time to analyze them. And over time, over the years, as you've improved your software, you've made the crash reports easier to parse. But you still have the old ones coming in, and sometimes something happens out in the world and users trigger new bugs in old code. So you still want to watch those old crash reports. So you are trying to analyze all that. And it would be hard to put it in a relational database because first you'd have to come up with a script that can find all the common elements among all the different messy crash reports. And you'd have to get it into a table and then figure out what queries you want to run on the table. And then if that table got extremely large, some of those queries are going to be slow. If, on the other hand, you just jam all that data into Couchbase or another NoSQL that has some kind of incremental MapReduce, then you can write a view that will figure out the salient points from those crash logs and give them to you in a normalized format. So maybe your old crash logs, you have to run a regex on them to figure it out. But the new one's nicely in there in a JSON format that you can just pluck out of the document. And there may have been other variations in timestamp format or whatever over the time, over the time your application's been out in the wild. So if you normalize that data during your indexing, then your application can be presented with a nice, clean, crisp view of the data, even though the underlying data reflects the messy reality of, the data your users is sending you. And for me, that feels like a really clean, elegant way to handle, that bridge between how messy the real world is and how, clean the programs that we write to operate on it, expect it to be. So there's one kind of superpower of this engine that I haven't talked about yet, is the ability to do really fast aggregations. If you've ever, had a slow sum or count query in MySQL, that's because, often the query planner is going to run the where statement first, and then it has this big bag of rows, and it has to count or sum those values. And that's a linear operation. So if you have lots of values, that's going to take time. With Couchbase MapReduce, you can put in as long as your index, as long as the values you care about are next to each other in the index, as long as it's contiguous, you can give a range query, and it will give back the aggregate across that range in logarithmic time instead of linear time, which means that even for ranges that contain very many documents, you can get a fast response. So a use case would be for instance, a leaderboard, if the key you emit is always if the key you emit for a leaderboard is the user ID, right, and say the number of points they won in the game, and then you can build a view that shows, across for every user across all the games they've ever played, how many points have they scored, and easily get that roll up. You can submit to that same index another query, a start key end key range that encompasses all users instead of just one user, and find out how many points have been scored across all your games. So similarly, if your keys were timestamps or timestamp segments, like an array, right, like 2005, 3, 14, right now, and the value is the number of clicks an ad got that day. Now you can use the summation reduce to give you dynamically, right? Say you want to know on a month-by-month basis, January, February, March, what the total number of clicks for that ad was. And then the same index can also provide the roll-up for all of 2012, or give you fine-grained information all the way down to the second granularity, whatever your timestamps are. So you can have a single index that allows you to do, all these really interesting aggregation and roll-ups. And so that's why I get excited about using that kind of in front of a Hadoop job. So Hadoop is, handling your archive, but then Couchbase is giving you real-time roll-ups. So there's a question that I see out here. The question is about the interface on the screen. Is this in the current release or 2.0 preview? The answer is this is in 2.0 preview, and there are a couple little details. This is a screenshot from my development laptop, and I'm working on a feature. One of the things is that actual function, kind of the template function. I'm playing around with that as an idea for what would be a good function for people to see the first time they get started. I know it looks a little bit hairy, but the thing is it gives you some interesting information no matter what's in your database. So kind of thinking through that right now. About to wrap it up here. If you have more questions you want to submit, go ahead and get them in because we do have some time for Q&A. The last little topic I want to talk about is, what kind of workloads are appropriate for NoSQL. Because I think there's a misperception, among some people that it's only, really valid for rapid prototyping, or for if you're really, stuck and have to scale. But there's a lot of enterprise applications that are moving to NoSQL, moving to Couchbase. We're, building and have been building, upon our work with customers for years to offer, the kind of stuff that you need when you're in production. So this is just the kind of screenshot from the stats UI. It's, a very small subset of what, we also have a REST API that you can integrate with to see what else is going on in your cluster. I just put this up because I like to show the amount of visibility and kind of some of the key things you can see in here. One of the stats we offer is the cache miss ratio. So if your cache misses start to go up, that means you have got, your working set is larger than your available RAM, and you need to dedicate, more RAM to your cluster. And then the other key stat is in the corner there, disk write queue, and that'll tell you if your aggregate disk throughput can keep up. So it's little things like that that allow you to really have visibility in operations that make it so that people are taking Couchbase seriously, putting it on the front lines of their business. So I don't know the details about every single customer engagement, but we have done some some pretty fun stuff and some pretty big things. Some of my favorites we might not even be allowed to tell you. Q3, Q4, and I guess, let's see, sometime in October, I can say that much. So we're going to be having 2.0 come out soon, and it contains the MapReduce query capability. So if you've been looking for that in the 1.8 release, that's not there yet. There's a bunch of other goodies in 2.0, like cross-data center replication, some performance enhancements and other stuff. But the key thing we talked about here, the query engine, you've got to download 2.0 from our website if you want to play with that. And that's currently in developer preview. I guess we have nightly builds coming out now, more or less, or I guess almost nightly builds. And then we'll be doing our beta release soon. So there's a question about Windows PHP client. Yeah, it's a good question. I'm not really the guy to know the details on that, so let me write it down. The Couchbase mailing list on Google Groups is a good place to go for questions and specifics like that. We also have IRC channels. We've got a forum on our website if you prefer that. And you can also just shout at us on Twitter. That's a good way to get questions like that to, you know, broad audience, people who are paying attention about Couchbase. Yeah, last thing I want to mention is we're hiring. We're looking for, you know, kind of, you can imagine, you know, that we'd be looking for everything from, you know, QA test engineers to, you know, people who want to work with the query engine or, you know, work on research projects for, you know, kind of new advanced, awesome NoSQL query engines, or database, you know, or Memcache performance optimizations, network, hardware stuff. If any of that floats your boat, let us know. And then the last thing I want to show, just because, you know, sometimes it gets a little lost in all the everything else that, you know, we talk about, but just to make it really clear that, you know, everything Couchbase does is open source. So this is, you know, our code review dashboard. Right? I can see everything that has happened. You know, these are, and this isn't even like trunk, right? This isn't like watching our GitHub. This is all the stuff that might go into trunk. So you can really get involved in development if you are a fan of open source. Everything we do is Apache licensed, and it's, you know, sitting here ready for you to, you know, log in with your OpenID and submit patches. So with that, I guess I'll bring it to a close unless there's any other questions people want to ask. So yeah, thanks again for joining us, and we'll have another webinar coming up on the 26th in, you know, just a few weeks for administrators, where we'll talk a lot more about the stats and the, you know, the ability to put Couchbase and NoSQL into production. I hope this was what you were looking for, and please join us again soon.